Welcome to Study Loop.
So in this question, the air flowing at specified supersonic Mach number is forced to turn upward by a ramp and weak oblique shock forms. So we have to find out the wave angle, the Mach number, the pressure and the temperature after the shock that we have to find. So here also, similar to the previous question, we have to take certain assumptions. First, as we all know, we have to take that flow is steady. That is the first assumption that we are considering. Now, then we understand the boundary layer is very thin. Okay, this is the second one. And the third is that air is a air is an ideal gas with constant specific heat. So these are the assumptions that we took. Now, as we move forward, we have to understand certain properties of the air also. So the specific heat ratio of air is 1.4. Now, on the basis of the assumption to that is the boundary layer on the wedge is very thin. We take the deflection angle as equal to the ramp. That is, deflection angle is as equal to the ramp, and that is given to be 8 degrees. So then the two values of oblique shock angle beta are to be determined from the equation. Tan theta equals to tan theta here 2 ma1 square sine square beta minus 1 upon tan beta divided by ma1 square k plus cos 2 beta plus 2. So keeping all the values, we'll then find out that. So we see that is equals to V strong, V weak. Okay, that is equals to 37.21 degree and beta strong equals to 85.05 degree. Now moving forward, we get that ma1n equals to ma1 sine beta and that is equals to 1.209. Now from this equation, the downstream normal Mach number and that is ma2n. So that is root of k minus 1 ma1 square plus 2 upon 2k ma1 square minus k plus 1. Keeping all the values, we get it to be 0.8363. Now, the downstream pressure and temperature are to be determined here. So, the pressure formula is we have 2k ma1 n square minus k plus 1 upon k plus 1. So the value would be 18.5 units. Then we have T2 and that is T1 into P2 upon P1, rho 1 upon rho 2 and that is equals to T1 upon P2 upon P1 into 2 plus K minus 1 ma1 square n upon k plus 1 ma1 square n. So considering this, we get the value to be 556 R. And the downstream Mach number, this ma2 equals to ma2n upon sine beta minus theta and that is equals to 0.7. So these are the three values that we require. I hope you understood. Thank you.